Direct and inverse variation. You have learned about direct proportions. Two quantities are said to be in direct proportions if one quantity increases as the other quantity increases. In other words, two variables x and y are said to be in direct proportion if x over y is equal to some constant k or x is equal to k times y. We can see some other situation where two quantities vary such that when one quantity increases, the other quantity decreases, and vice versa. Let us learn about it now. Let us consider one example. Suppose that there are 48 chocolates which are to be distributed equally among children. Say there are only 2 children. Both will get 24 chocolates each. Suppose that 2 more children join them. Now if we want to distribute the chocolates equally among the 4 children, how many chocolates will each of them get? Each child will get 12 chocolates. If there are 12 children, each child will get 4 chocolates. Now, what pattern do you notice between the variation of the two quantities? Observe the first 2 columns of the table. At first, the chocolates were distributed between 2 children. The number of chocolates each child will get is 24. When there are 4 children, the number of chocolates each will get is 12. Observe that as the number of children got doubled, the number of chocolates that each child gets is divided into half. Similarly, as the number of children increased from 4 to 12, that is 3 times, the number of chocolates that each child gets decreased to 4, that is 1/3. We can say that as the number of children increases, the number of chocolates each child will get decreases. Now, if the number of children is halved from 12 to 6, what will be the number of chocolates that each child will get? In this case, the number of chocolates that each child will get must be doubled to 8. Thus, we see a pattern between the two quantities, the number of chocolates and the number of children. When one quantity increases, there is a proportionate decrease in the other quantity. Such a change in two quantities is called inverse proportion. Inverse proportion of quantities can also be expressed mathematically. Let's see how. Let us denote the number of children as x and the number of chocolates as y. We can notice that xy is 48 for all the cases and thus it is constant. Or in general, two variables x and y are said to vary in inverse proportion if there exists a relation of the type xy equal to k, where k is constant. Thus here we can say that x is directly proportional to 1 over y. But 1 over y is the reciprocal of y, which is also called the multiplicative inverse of y. X is directly proportional to the inverse of y and is written as shown here. This relation is also read as x is inversely proportional to y. Thus, when two varying quantities x and y are in direct proportion, x over y is a constant. And when they are in inverse proportion, their product xy is a constant. In case of inverse proportion, we can generalize in the following way. If y1 and y2 are the values of y corresponding to x1 and x2 of x respectively, then x1 y1 is equal to x2 y2 is equal to k. Let us take one more example. Suppose that a painter takes 30 days to paint a house. If the painting is to be completed in 15 days only, then how should the work be divided? If the job of painting the house is divided among 2 painters, it will be completed in half the time, that is 15 days. We get this result because 30 divided by 2 is 15. Therefore, the work should be divided among 2 painters so that it will be completed in 15 days. Similarly, we can observe that if 3 painters share this job, they will finish painting the house in only 10 days. If 5 painters together paint the house, can you find the number of days they will take to complete the job? If 5 painters paint the house, they will take 30 divided by 5, that is 6 days, to complete the painting. Real-life example. Now let us observe some examples in our real life where we can see inverse proportions. Suppose that there is a park which is 1 kilometer away from your home. If you walk slowly, you need half an hour to reach there. If you walk faster, you will reach the park in 15 minutes. That means the speed at which you walk and the time taken by you to reach the park is inversely proportional. If you increase your speed, you will reach in lesser time. Now let us consider the example of the population of a country and the area of land per person. As the population increases, the area of land per person decreases. So the population and the area of land per person are in inverse proportion. Let us now solve few problems related to inverse proportions. There are 100 students in a hostel. Food provision for them is for 20 days. How long will these provisions last if 25 more students join the group? Suppose the provisions last for y days when the number of students is 125. Let us tabulate the given data. Note that more the number of students, the sooner would the provisions exhaust. Therefore, this is a case of inverse proportion. So from the table, we can write 100 multiplied by 20 is equal to 125 multiplied by y. Or by cross-multiplying, we get 100 into 20 divided by 125 is equal to y. By simplifying, we get y is equal to 16. Thus, the provisions will last for 16 days if 25 more students join the hostel. If 30 men construct a compound wall in 20 days, how many men will be required to do the same work in 15 days? Let's take the number of men required to build the wall in 15 days as y. Using the given information, we get the table as shown here. It is obvious that with more number of men, the construction will take less time. So the number of days and number of men vary in inverse proportion. Using the relation for inverse proportion, we find the number of men required to construct the wall in 15 days. Let us take another example. A school purchases 20 blackboards at rupees 750 each. With the same amount, how many blackboards of higher quality costing rupees 1000 each can the school purchase? Let the number of blackboards of higher quality that the school can purchase be x. From the information provided, we get the table shown here. With the cost of one blackboard going up, the number of blackboards that the school can buy will go down. So the number of blackboards and the cost of each board vary in inverse proportion. We thus find the answer using the relation of inverse proportion as shown here. Thus, school can purchase 15 blackboards of higher quality with rupees 1,000. Summary. Let us summarize what we have learned. Two quantities x and y are said to be in inverse proportion if an increase in x causes a proportional decrease in y and vice versa, in such a manner that the product of their corresponding values remains constant. If xy is equal to k, then x and y are said to vary inversely. If y1 and y2 are the values of y corresponding to x1 and x2 of x respectively, then x1 y1 is equal to x2 y2 equal to k, or x1 over x2 is equal to y2 over y1.